So when you graph this, where are my zeros? Let's go ahead and start with that, because that's what we talked about yesterday. Okay, so we're going to write that down here where it says 0. So we're going to say x is equal to -4, -2, and 0. Okay. Now, for domain and range, okay, let's talk about domain. Domain for this function is going to be all real numbers. So the way we write that out is we say from -infinity to +infinity. For range, it's also going to be the same thing, -infinity to +infinity. That's your y values. Okay, the domain is your x, range is your y's. What are my maximums and minimums? Okay, so that's going to be our turning points. So our relative minimum is going to be -0.845, comma -3.079. And our maximum is going to be -3.155, 3.079. For intervals of increase and decrease, remember that's when the y values are increasing or decreasing. So that's going to happen right here. We're going to increase right here from -infinity to -3.155. We're going to decrease right here. So that's going to be from -3.155 to -0.845. And then we're going to increase again at -0.845 to +infinity. Is going to be as x approaches to the right, my y values are going to increase. As x approaches to the left, my y values are decreasing. The parent function is going to be y equals x to the third, okay? When you find the parent function, it's your, like, no transformations, your basic function, and that's going to be the x to the third. We're going to divide this by x minus 2. So really quick, we're going to do this through synthetic. That means we're going to switch the sign, list out our coefficient, bring down our first term, multiply, add, multiply, add. So this is going to give us 3x plus 14 plus 24 divided by x minus 2. Same thing on this next one. We're going to switch the sign. And we're going to list out our coefficients. So 1, -3, 6, and 8. We're going to bring down our first term, multiply, add, multiply, add, multiply, add. We're going to take it down one exponent. And that's going to leave us with a remainder of -2 over x plus 1. Again, we're going to talk about something called the remainder theorem, okay, to evaluate whether something is a factor or not. Okay, so looking at this next problem, this says, go ahead and divide this out. And I think these were the warm-up problems, so really quick, let me just copy this down. Okay, so this is from the warm-up problem. We're going to take these two things and write them up here. We're going to have 3x plus 14 plus 24 over x minus 2. And this one is going to be 1x squared minus 4x plus 10 plus negative 2 over x plus 1. Again, those are from the activating strategy on this paper. So what you're going to do now is you're going to find f of 2. Okay, so what that's asking you to do is to take your function, your original, and plug 2 into it. So we're going to take 3x squared plus 8x minus 4, and we're going to plug 2 in for every x. And we're going to simplify this. The 2 squared would give me 4. 4 times 3 is going to give me 12. 8 times 2 is 16. And then minus 4. 12 plus 16 is 28. 28 minus 4 is 24. What do you notice? Okay. What do you notice by comparison of what's up here? Is there anything similar? What do you mean the same thing? So this remainder is the same thing as what we got down here. Okay, so the remainder is the same as the number. Okay, take a moment, find g of -1. So again, that's taking the original and plugging in -1. See if you get, all right, so when we plug in -1, and we simplify, this is going to give us -1 minus 3 minus 6 plus 8. So -1 minus 3 is going to give us -4. -4 minus 6 is -10. -10 plus 8 is going to give us -2. Is this the same thing as this remainder? Yes. Okay. So one thing that you want to keep in mind is whatever they're dividing by, you're going to switch the sign and plug it in. Okay, so just like what we did here, we switched the sign and then we plugged it into the function. So use your observations about dividing and evaluating to make a general rule. If a polynomial is divided by x minus a, then the remainder tells you the value of, this means the point is on the polynomial. Okay, so this is telling you the value of f of a. And this is telling you the point a r. Okay. So how would this help you find the zeros of a function? Okay. Well, this would tell you that if the remainder is 0, then whatever you just plugged in, so whatever a is a factor. I'm sorry, is a 0 of the function. All right, so let's make a prediction. So look at this graph. What do you expect to get when you divide g of x by x plus 5, x plus 3, x minus 4, and x minus 6? Okay, so really quick. When I plug in -5, what's going to be my y value? What's my y value from this graph? Am I just talking to myself? So if I plug in -5 and I look at my graph, what is my y value going to be? This point right here, which is 0. When I plug in -3, what do you expect my y value to be? 1, 2, 3. 6. When I plug in 0, I expect my y value to be 0. When I plug in 4, I expect my y value to be 0. And when I plug in 6, I expect my y value to be, I think that's like 7. Okay, so notice how I changed the sign of all of these guys. Get my x, and then I looked at my y value. So these are my x values, these are my y values. At the x-intercepts. Okay, so remember the x-intercepts are where it crosses the x-axis. What is the remainder when you divide the polynomial by a factor? Okay, so if I look here, this has an x-intercept at -5. It has an x-intercept at 0. And it has an x-intercept at 4. How do we write these out in factored form? Well, remember, we're going to switch the sign and put an x in front of it. So that's going to be x plus 5, x plus 0, or you could just say x on that one. And then x minus 4. If you took any of these and divided the original function by these things, your remainders are all going to be 0, because these are all zeros of the function. So the remainder theorem is just a fancy way of saying, if you take the number and you plug it in, you'll get whatever the y value is. So when you divide a polynomial by its factor, you get a remainder of 0. Determine when the given binomial is a factor of the polynomial. Okay, so there's a couple different ways you can do this. You can take this and you can divide by x minus 3. Okay, but you can also switch the sign of this one and plug it into this function. So this will be +3. So f of 3 equals 3 squared plus 2 times 3 minus 3. So I switched the sign and plugged in. So now I'm going to simplify. So 3 squared is going to give us 9. 3 times 3 is 6 minus 3. 9 plus 6 is going to give us 15. 15 minus 3 is going to give us 12. Is x minus 3 going to be a factor? No, because this number right here that we got at the end is not equal to 0. So this is not a factor.
You also can graph the function,
Mm-hmm.
and if the graph is not touching the 3, that means it is not a factor also.
Definitely not. Yeah. Go ahead and take a second, try B. All right, so again, if you want to do this the remainder theorem way, that's fine. You can also, if you don't like plugging in, if you don't have like a calculator to kind of simplify this, you can do this the synthetic way. Okay, and it should get you the same results. So when we bring this down, we multiply, add, multiply, add, multiply, oops, nope. Multiply, add, multiply. Notice how 0 is our remainder. So is this guy a factor? Yes. Okay. Now you could have done this the other way. You could have said, all right, let me take -4 and plug it in all the way through here. You're going to get 0 when you do that. So it doesn't matter which way you want to do it. I personally think that the synthetic way is easier just because I have to deal with smaller numbers. All right, so last part. If you took these and plugged them straight in, This is going to give you 9 minus 6 minus 3. That's going to give you 0. So is this a 0 of the polynomial? Yes. If we took 4 and plugged it in, this is going to be no. This is not going to be 0. Okay. What?